In section 1.6, we cover equations and inequalities involving absolute value. So what we mean by that is an equation with an absolute value sign could be something like this. Now, how we solve this is we want to isolate the absolute value first. Okay, so that's going to be 2x minus 3. So add 5 to both sides. We get 2x minus 3 equal 13. And then from here, we split this into two separate situations, either equal to 13 or equal to negative 13. And the reason we do this is because if we have something like this, let's say that that is equal to 5, well, x could be positive 5 or x could be negative 5. So we follow the same idea when we're solving any equation that has an absolute value sign. From here we're going to say 2x minus 3 is equal to 13, and 2x minus 3 is equal to negative 13. And then we just solve each of these little equations on separately. So 2x is equal to 16, x equals 8, and then 2x is equal to negative 10, x is equal to negative 5. So these would be the two solutions here to this inequality, or rather, this absolute value equation. All right, next we have an absolute value inequality. And what we're going to do is, just like when we saw in 1.5, a regular inequality, we want to solve, we want to graph on a number line, and we want to write the solution in interval notation. Okay, so we still need to split this up into two inequalities. So the first one we write exactly the same, 4x minus 1 less than or equal to 9. And then the second inequality, we keep the left side, or what's inside the inequality, the exact same. But what we do is we reverse the inequality symbol and we change the sign on that value. So this is going to be 4x minus 1 is greater than or equal to negative 9. And then in here, in between, we're either going to write and or. And it just depends on which way the original inequality is going. Okay, so less than or less than, we're going to use and. If it's greater than or equal to or greater than, we're going to use or. So kind of a silly way that we can remember this. This is less than, okay? And then greater, well, we can say that as greater. Okay, so if it's a greater than or equal to or greater than, we're going to use or. If it's less than or equal to or just less than, it's going to be less than, so we'll use an and symbol. Okay, so this one is less than, so this is going to be an and in here. And all that means is, because it's and, our solution is going to converge. It's going to come together. This would be an and. If it's an or inequality, the solution is going to go apart from each other. And I'm just randomly picking whether to use brackets or parentheses. So if it's an and, it goes together. If it's or, it goes away from each other. All right, so let's solve each of these little inequalities. So 4x less than or equal to 10, x is less than or equal to 10/4, which is 5/2, and 4x greater than or equal to negative 8, x is greater than or equal to negative 2. Okay, so I'll just graph each of these separately. X is less than or equal to 5/2, so something like this. X is greater than or equal to negative 2. looks something like this. Now, because this is an and, the graph is going to converge. It's going to come together. So writing both of these graphs on a single number line, we're going to say bracket on -2, bracket on on 5/2, and we're going to shade in between. And then once we have the graph, it's really easy to then write interval notation. So these are the solutions, and then here's the number line, and here's the value or the interval notation of the solution. All right, and one last example here, another absolute value inequality. So we're going to split this up into 2x minus 8 greater than or equal to 4. Now because this is greater or equal to, we're going to say this is going to be an OR inequality. And that just means the graph is going to go to negative infinity and positive infinity. The two parts of the graph are going to be going away from each other. So 2x minus 8 less than or equal to -4. Remember, reverse the inequality, change the sign, and then we just solve these separately. 2x greater than or equal to 12, x is greater than or equal to 6, or 2x is less than or equal to 4, x is less than or equal to 2 here. So on the number line, wait a second, this is not right here. This should be 6. X is greater than or equal to 6, x is less than or equal to 2. So plot both of these values on the number line. We'll have 6, we'll have 2. Because this is an OR, the graphs are going to go away from each other. So we're going to have less than or equal to 2, and then greater than or equal to 6. And then writing this on a number line, we're going to say negative infinity to 2, union 6 to infinity. And that'll do it.